Welcome back to our series on open segment construction. This is the second part of 3. And last time I showed you, not this piece, but a similar one, where we assembled each layer, one segment at a time, on the lathe using an indexing system. Well, in this one I'm going to show you another way of doing this, not using the lathe as an assembly fixture, but using a separate device off the lathe. I did something unique. Here's the piece that you'll watch me build. And if you look at this carefully, you'll find that the spacing between the light-colored segments is different than between the dark-colored segments. And because the software would not help me be able to do this mixed combination, I had to produce my own spreadsheet. And you'll see me in the video referring to this a number of times. So let's go take a look at how I cut and assembled the two halves of this vessel, which we will turn in the next portion of this 3-part series. So let's look at the video, and then we'll come back and talk about the fixture. This is a second technique for doing open segment construction, in which case the pieces are placed in the project individually but off the lathe. I've assembled a piece which has different spacing for each layer, and therefore it's been easier for me to make up my own cut sheet. I prepared each of the boards that will be used for each of the layers individually. They have been sanded flat and cut to the segment width and are ready now to be cut to the segment edge length. So I'm setting my stop for the proper segment edge length. I'm going to cut the lighter colored wood into proper segments first. Since the spacing is different because the light and the dark wood, this angle needs to be set at 11 degrees. And since these segments don't touch each other, precise, accurate cutting is not as necessary as with ring segmented work. So a miter sled such as this one is more than adequate to create the spacing that I would prefer. So the blade has been raised, checked. I have strip number 2. I've pre-numbered each of these, checking to be sure the blade is tall enough, checking my math, and proceeding now to cut all the segments for level number 2. Trim the end to the proper angle, and in this case we'll just flip the board against the stop and make the cuts. So 11 degrees flipped, 11 degrees. The included angle in this case is 22 degrees. And we'll proceed to cut all of the light colored woods exactly the same way. And now I'm going to cut the other wood for this project, which are thinner slices of bloodwood. That is an 1/8 inch thick, and in this case, the darker colored wood is cut at 13.5 degrees because the gap between each of these segments is going to be much, much smaller. So we set that up, and just like the thicker pieces, each of the segments are cut. And when we finish cutting all these pieces for each layer, the pieces are put into a plastic bag, and the bag numbered, and then all of the pieces taken to the lathe where the assembly is going to be done. We're starting the assembly with a solid ring at the top. I'm going to show you top-down portion. This is a Wenge ring that was part of another project I had split. So I've checked it out. It looks like it'll be just about the right dimension, but it needs to be flattened. And so I've got it on the lathe, and the first thing I'll do is make a couple of cuts across here to be sure that the surface is dead flat. After every level is flattened, I'm going to use the sanding stick to finally true up that layer. The sanding stick I'm using here has 120 grit sandpaper, which seems to be more than fine enough to do the job that's necessary. So we'll flatten it, and then it'll be ready to start building the project, in this case, top down. Top down to a point in the vessel where the top and bottom sections match with an almost vertical side. So here's the fixture that we're going to use. I call this the Driscoll fixture, but it's a place built around an indexing plate and a fixture that allows us to screw a faceplate onto one surface. The fixture has the indexing plate captured tightly, and the holes I'm going to use are marked. I've marked 24 holes with a circle and 24. Let me correct that. I've marked 12 circles, 12 holes, and 12 with a line. I'm doing all the measurements in metric inches, simply because it's easier off of the spreadsheet to do that. My fixture, though, has a imperial fractional inch tape on it, which could have also been used. So, first layer to be added is the topmost, and this is a dark, thin layer, in which case the angle between each of the pieces is very small. And in the case of narrow gaps, you need to be sure that you haven't cut the segment edge length too long, or it'll be a difficulty of fitting them together, and you'll see how close they come. I'm using my Tite Bond Original glue. It's about 80 degrees in the shop right now, and we do not have a problem with glue setting. It'll tack in a few seconds, and it'll never be touched until the whole level is completed. And so gravity is my friend. And I'm going to check to see how much glue I actually need. Don't want to put too much on. A little bit of glue being applied with a stick and just placed up against the stop. And at this point, I'm done. I'm going to go over to the next hole for the next round. This is the next hole that has a circle marked on it. And I could have pre-sanded the edges of all these pieces. I just didn't. I could have. That might have speeded me up just a little bit more. But at some point in the project, the sanding has to be done. I'm being sure I didn't put too much glue onto this piece. I thought maybe I had added a little extra. And as you can see, the spacing on this top ring is very tight. Over to the next hole, the next segment, and so on. For this last segment in this row, because the spacing is so tight, there's no room for the arm to set between the individual segments. Although it's a very thin piece of aluminum, it won't fit. But because the spacing is tight, placing this piece by eye is not going to be a difficulty. On other rows where the spacing is a little broader, I can leave the arm down and use it to place the segments. Glue dry, remove from the fixture, visit to the lathe, and flatten this ring. Make the first strokes with the sanding stick very light in case a corner or an edge is sticked up too proud. You can generally hear that sound, and when the sound is continuous, the thought is that the ring is probably pretty flat. But we always will check it. We do that by striping a pencil line across the surface of it, taking a couple of additional strokes with the sanding stick, and then checking to see if there's any pencil marks remaining. And not finding any, I'm good to go back to the fixture and proceed on to the next layer. When you screw these fixtures back on, be sure not to over-tighten or under-tighten. You need to come up with the same tension as you did last time, or the alignments may change. This level is going to be oak. And again, we're checking the radius. I've put in my spreadsheet the diameter and then calculated the radius and then printed that also, just to be absolutely certain that I made no errors. Oak is very porous wood, so sanding each of these pieces is very necessary. And as with the former ring, placing these pieces is as simple as that. Putting the piece in place, indexing over 1/12 of a circle, sanding, gluing, and placing the next piece. Well, for both top and bottom, the process is exactly the same, and we keep going through it, placing a piece, sanding a piece, gluing it down, and the next, until we get down to that last piece in the circle. And in this case, the last piece is going to be very easy to put back in place because we have the spacing available between the pieces for that arm to sit in place. And like every layer, when the glue is dried for about 15 minutes, we'll go in there and with a damp pipe cleaner between each of the segments, try to remove any excess glue that might be visible. While it dries clear, globs in between here is not going to look very good, so we clean that up. And it's a little easier sometimes with the horizontal setting. And here we do the sanding stick again, cautiously at first, with a little more pressure as we go on, checking with the pencil mark, and proceeding on. The next layer and the next layer are all going to be done the same way, and the bottom up will be done exactly the same way. So here's the completion of the top layer for this particular vessel. It's done, it's sanded. And in the next portion of this video series, I will actually show you the turning of this. But here's the two halves, bottom half and top half. And we'll put these pieces together and we'll turn this into a vessel in the next video. Well, you saw how I cut and put the pieces together using this fixture, which I call the Driscoll fixture, after Jim Driscoll, who was the first one who showed me a version of this many, many years ago. I want to take you through some of the features of this. First thing you saw is this movable arm, which goes, obviously sets on the top of each layer. this arm comes right to the center of rotation so that I'm measuring each segment out at the radius of that level. Software will tell you diameter, but we need to divide that by 2 because I'm going to put each piece against this stop at the radius and then index around and so on. So that's one of the features. The other thing about this, I'm just trying to get this up out of the way here. I used an indexing plate. This is the iron fire one that we referred to in the last section. I'm doing 12 segment rings. So I marked off with circles on this 96 ring where the dark pieces would go. And then halfway in between with a mark, a line, I marked where the light pieces would go, so I don't have to stop and count as I go. So this works with any indexing plate. Now, when this was first devised, Jim Driscoll made a fixture. I'm disassembling this for a second here. And the way the fixtures he had worked was like this. It had a flat surface that would ride on your bearing here. You drop this on top of it and lock it down with a faceplate. And we can keep this from rotating by simply putting the peg in the hole and holding that. You saw me in the video taking the assembly off, going to the lathe, flattening this surface, and then bringing it back and putting it on here. The difficulty with this, meanwhile, things could slip. Or I could tighten this more or less than I did last time. As a result, indexing might not stay perfect. So I have redesigned Jim's original adapter. First adaptation I did was to simply pull it into 2 parts and rough the surface up here so that it'll grab these plastic or steel or aluminum plates better. It didn't much help. Here's the fixture I now use. And you'll have to make one of these because there's no source that I'm aware of that manufactures and sells these. So here's a bearing surface. Here's the thread for the faceplates I'm using. This is a 1 1/4 by 8. Sets in here. Indexing plate goes on. And then I have a washer that when screwed down really good and tight will lock this plate into place. And again, we put the pin in the hole. And then when I screw the faceplate on, it comes down to register against this washer. And I take it off, go to the lathe, come back. You still need to be very cautious that when you tighten this faceplate down, that you torque it to about the same amount. We can set the last row on, bring this arm down, and set it back into exactly the same place it was, and then index over the right amount for the next ring. So I need to be cautious about that. The other thing that I have here, I have 2 different pins. This is the one I made to fit the Ironfire LLC plate, but for some of the other plates you need a different size pin. So I have 2 different ones. So when you buy an indexing plate, be sure that you have a pin that's appropriate that fits the holes snugly so we don't have a little bit of wobble and wiggle as we go. I've used a piece of aluminum angle that I just got at the hardware store. I found the thinnest I could get. The point is that this portion here sits down in between these segments. When we're tapping that last piece, we need to have the room to have that clearance. And you saw on one layer, the very first layer I did, the pieces were so close that even this thin amount here was too thick. And I added that last 12th piece by eye. Well, when it's that tight, you can't possibly get it too far off. So, a Driscoll fixture, which I built, first thing I did was to drill this hole, which fits this. And then this arm was constructed so that this corner right here lands perfectly with the center of rotation, and that's important. And everything else is pretty simple. So you'll have to have one of these devices, or make one of these devices. And you saw me last week in the last video at the lathe, and I needed to add a spacer like this to the headstock of the lathe before I mounted the indexing plate. The reason is there was a recess behind the threads on my lathe that would have allowed the indexing plate to drop down in here and not align perfectly. So this went onto the headstock. I then put on the indexing plate and locked it down like this, and that worked perfectly well. So a wood ring would have worked. I happen to have the ability to make one in steel. So this is a way of doing segmented turning off the lathe. The advantages is I can work much more rapidly and when I install the segments. The disadvantage is I have to take the assembly off of the fixture and to the lathe and flatten at every single level and then return it to the fixture. There's advantages and disadvantages to all different methods. I don't know if I prefer this one over the other one. I certainly use this technique probably more than the other one. And there's a third method. And in the third part of this video, I'll show you the third method. There's two ways it can be used. And I also will put these pieces onto the lathe and will actually turn this vessel. So thanks for watching. Subscribe, give us your comments and questions, and I'll see you back in the last part of our open segment presentation.